We continue evaluating determinant. Example 4. Use the expansion method to evaluate the determinant. This determinant has 4 rows, 4 columns. It's a 4 by 4. Then the first method in previous example, the green line, pink line, would not apply here. So the only way we could solve this, we could evaluate this determinant is the expansion method. We could expand the determinant from one row or one column. We could pick any row or any column, but we want a row or column has as many zeros as possible. So I'm going to do this row 3, because half of the entries are zeros. Would be very convenient. Let's see how do we expand it. The first entry 4 is in row 3, column 1, so that is A sub 3, 1. Multiplied by is a cofactor A, capital letter A, 3, 1. 0, row 3, column 2, so A 3, 2, A 3, 2. This is 0, 3, 3. This is 3, 4. Cofactor is a sign multiplied by minor. The sign for the cofactor of A sub 3, 1 would be -1 to the power of 3 plus 1. M31 plus A32, -1 to the power of 3 plus 2. You should see the pattern in previous video. How do we determine the sign here? Multiply by the minor. For the purpose of the day quiz, you have to know what is minor. And plus A33, -1 to the power of 3 plus 3, minor A34, -1 to the power of 3 plus 4, minor 34. Okay. So the first entry, A sub 3, 1, that's 4. And -1 to the power of 3 plus 1. What's the minor of 4? We cross out row 3, column 1. The rest of entries gives us a 3 by 3 determinant. That is -1, -3, 0, 3, 1, 5, 0, 1, 0. And what about here? A3, 2. So you would see the benefit or the convenience if you choose a row or column with as many zeros as possible, because A sub 3, 2 is 0, so we don't have this term anymore. The same reason A3, 3 is 0, so 0 times anything is just 0, so we don't have this part anymore. A3, 4, that is 1. 1 times -1 to the power of 3 plus 4. The minor of 1, we cross out this row, this column. The rest of the entries give us 3 by 3 determinant, -2, -1, -3. Be very careful, because you need to be very careful. Otherwise, even just mess up one value, one number, everything would be different. 3, 3, 1. 2, 0, 1. Originally, we need to solve or evaluate a 4 by 4, one 4 by 4 determinant. By the expansion method, we have 2 3 by 3 determinant. Of course, 3 by 3 determinant is easier to solve. It's easier to be evaluated. So this is going to be positive 4. So do you want to, let me use the method we learned earlier to evaluate that 3 by 3 determinant. -1, 3, 0. -3, 1, 1. 0, 5, 0. You could actually expand from the row 3. It also would work. You can try that on your own. I copy column 1 here, column 2 here. This is the main diagonal, and the main diagonal. And the pink one is the vice diagonal, vice diagonal, vice diagonal. So let's see what we have. The green one, 0. Second green line, 0. Third green line, also 0. Okay, so pink line, 0, minus 0. Pink, this one is a -5, but we change the sign because for the vice direction, vice diagonal direction, we take the opposite. So 1 times 5 times -1 is -5, but we keep the opposite. And this is 0. So we have 5. We end up 5 here. Okay, we have 5 here. Let me double check. 0, 0, 0, 0, positive 5. Okay, very good. So this one, 3 plus 7, 3 plus 4, 7, that's going to be negative. And for this determinant, we're going to use the same method. -2, 3, 2, -1, 3, 0, -3, 1, 1. Copy column 1, column 2. Oh, we don't need a bar here. So main diagonal, main diagonal, main diagonal, vice, vice, vice. For the green lines, we're going to take the positive. So this one is a -6. -6. This one is -2. This is a 0. Pink line, this is 18. -18, but we take the opposite. So positive 18. This is a 0. This is a -3, but we take the opposite, positive 3. We end up with 5. Let me double check. This, no, 13. Hold on. So this is -8 plus 18, 10. 10 plus 3, 13. So 20 minus 13 equals 7. 7 is the value of the original 4x4 determinant. For 4x4, we would have to apply the expansion method. Example 5. Where's my example 5? Let's give the surface a second to react. Example 5. From example 5, we are going to learn a new concept, Cramer's rule. This is a theorem. This theorem provides us a different method to solve a system of linear equations in whatever how many variables. But this method only applies when the coefficient matrix of the system is a square matrix. In other words, the number of equations equals the number of variables. So this Cramer's rule is a theorem. This rule gives us a different method to solve a system of linear equations in many variables. But it only applies if the number of equations is equal to the number of variables in the system. So this is a very simple system. Only 2 equations, 2 variables. So Cramer's rule applies. I'm going to show you how do we apply Cramer's rule. You would know what is Cramer's rule and how do we apply it. Firstly, I want you to have the coefficient determinant. We have learned a coefficient matrix, right? Coefficient matrix. So you tell me what's the coefficient matrix of this system. In equation 1, coefficient of x is 1, coefficient of y is 6. In equation 2, coefficient of x is 3, coefficient of y is -1. So this is a matrix, right? It is a 2 by 2 square matrix. Coefficient determinant is just simply you take the determinant of the coefficient matrix. We use D, capital letter D to denote, to represent the coefficient determinant. Okay? And then we are going to construct or create another 2 by 2 determinant. Let me show you how, and pretty interesting. We're gonna derive D1 and D2. They are also 2 by 2 determinant from the coefficient determinant D. Okay, so in D1, we are going to keep column 1, change the column 2 in D. In D, column 2 is R6 -1, right? We're gonna get rid of those two numbers and replace them with the constant terms, 2 and -13. You see what I'm saying? The two constant terms on the right-hand side of the equation, we're going to use them to replace the column 2 in D to have D sub 1. Then you might guess, how do we create D2, right? D2, we're going to keep column 2 in D, 6 -1. And column 1 is going to be the two constants in the equations, 2, -13. All right, I'm going to give you a moment to digest. Coefficient determinant is easy to find, right? How do we derive D1 and D2 from D? How do we put the two constants term, 2 and -13, in the determinant to create D1 and D2? Okay, so let's evaluate them. We have the method for the 2 by 2 determinant, right? So this is the main diagonal. This is the vice diagonal. Okay, so let's see D. Main diagonal 1 times -1, -1, minus 3 times 6, 18. So we end up with -19. -19. Let me double check. -1 minus 18. Yeah, -19. D sub 1, we use the same way to evaluate. 1 times -13, -13 minus 2 times 6, also -19. D2, 2 times -1, -2, minus the product of 6 and -13. That's going to be -78. 13 times 6, yeah, 78. And that gives us -2 plus 78. That is 76. Okay? Okay, so while we're doing this, why do we need a D sub 1, D sub 2? Because that's the important pieces. Those are important pieces in Cramer's rule. By the Cramer's rule, the first variable, we are solving the system, right? So we are looking for the value for x and y. By the Cramer's rule, the first variable x equals d1 over d. The second variable equals d2 over d. That's the content of Cramer's rule. What is d sub 1? -19. What is d? -19. So x equals 1. What is d sub 2? 76. D, -19. So -4. Yeah. Let me double check the result. here. Did I D2, D sub 2? Oh, hold on. Oh, okay. You know what? Actually, I messed it up. Actually, this is D1. I apologize for that. This is D1. This is D2. Let me fix it. So if you see I made this mistake, then you don't make the same mistake. Actually, it's a good thing. It's more impressive, right? Now it's more impressive. So what is D sub 1? D sub 1 is you use the constant terms to replace the first column. Replace the first column. D sub 2 is you use the constant terms to replace the second column. Okay, so be very careful. Don't make the same mistake that I made earlier. So x equals D sub 1 over D, y equals D sub 2 over D. So as I said, this is more impressive, then you can remember it even better. Again, D sub 1, when we derive D1 and D2, D sub 1, you use the constant terms to replace column 1. And D sub 2, you use the constant terms to replace column 2. Okay? So you can make a conclusion. The solution of the original system is an ordered number pair -4, 1. Right? So that is Cramer's rule. That is Cramer's rule. So what if you have a system with three equations and 3 variables? For example, we got this x plus y minus z equals 1, 3x minus 4y minus 5z equals -1, 6x minus 3y plus z equals 20. In section 10.1, we use the algebraic method to solve this system. In section 10.2, we use the Gaussian elimination matrix method solve this system. So here we actually could use the Cramer's rule. Cramer is a mathematician's name. I think maybe he's French. To solve this system. The method applies because we have 3 equations, 3 variables. So by the Cramer's rule, we need to find D, D1, D2, and D3, right? Okay, so what is D? D is going to be a 3 by 3 determinant. We keep the coefficients of a variable x, y, z. We have 1, 1, -1, 3, -4, -5, 6, -3, 1. And you evaluate this determinant. So how do we find D1, D2, and D3? Be very careful. D1, the first column is going to be the constant term, 1, -1, 20. The column 2, column 3 going to be the same with D, 1, 4, 1, -4, -3, -1, -5, 1. And the D2, column 2 of D2 would be the constant term, 1, -1, 20. Let me double check, 1, -1, 20. And the column 1, 3 would be the same with D, 1, 3, 6, -1, -5, 1. And for D sub 3, the last column, column 3, would be the constant terms, 1, -1, 20. First 2 columns would be the same with D, 1, 3, 6, 1, -4, -3. Okay? So if we have time, I want to show you how do we use the calculator to evaluate the determinant. Okay, so firstly we go to, you would see matrix on above this key, matrix in blue. So second X inverse. And we go to 1, 2, and added matrix A. Matrix A is going to be 3 by 3. And those 9 entries would be 1, enter, 1, enter, -1, enter, 3, enter, -4, enter, -5, enter, 6, enter, -3, enter, 1, enter. So that's how do you construct the matrix in the determinant. And then you can quit. And then we go to the matrix again. This time we're gonna choose something from the math menu, the menu in the middle. And we're gonna choose the first function in the menu. The first function, as you see, is det of a parenthesis, right? Det represents determinant, so you choose that function, and then you're gonna put a matrix A in it, and you're gonna do the same thing earlier. Second X inverse, enter A, and then close the parenthesis, enter. You would have the value for the determinant, which is -67. Is that clear? You can repeat the video and figure that out. Same idea. You can use the calculator to evaluate D1, D2, and D3. Then X would be D1 over D, Y equals D2 over D, and Z equals D3 over D. And you can solve the system by using the Cramer's rule. So this is the third method that we have learned so far for solving a system, right? The first method, algebraic method. Second method, Gaussian elimination method. Third method, Cramer's rule. All right, thank you guys for watching this video. I'll see you next section.